This is Honda's 10-speed automatic transmission. This is Honda's first planetary gear transmission. The donor vehicle is a 2018 Honda Odyssey. A Honda 10-speed automatic transmission. Here we see the transmission controller, or the TCM, which is serviceable there externally of the case. Here we see the aluminum cover for the valve body and the solenoid assembly. Here we see the transmission oil cooler, or, and sometimes referred to as an oil warmer, where I simply have a plate-style heat exchanger, engine coolant on one side, transmission fluid on the other. With the Honda 10-speed automatic transmission, we do not have a dipstick. Instead, you'll notice that I have a fill plug and then a level test. So obviously I would simply fill the transmission until the transmission fluid level is at this point. And obviously Honda has a routine for doing this: engine at normal operating temperature, engine running, etc., etc., etc. Note the decal specifying the Honda transmission fluid desired in this unit. Now we're going to go ahead and disassemble the unit. This unit is from a vehicle with only 4,000 miles on it. The unit has been disassembled already, so it's clean and dry. For disassembling the automatic transmission, the first thing we're going to do is start by removing the oil cooler. Here it's retained with three 12mm bolts. One kind of rule of thumb and a good practice, especially with Honda's automatic transmissions, specifically the parallel shaft transmission, the 4-speed, the 5-speed, and the 6-speed, is after you remove a fastener from an auxiliary, put the fastener back. That way, after the rebuild process, you don't have to go looking for it. Now here we see their plate-style heat exchanger, engine coolant on one side, transmission fluid on the other. And here we have a filter, and what this is going to allow us to do is filter the automatic transmission fluid before it flows to the lubrication circuit. And this, of course, would be an excellent idea. Help protect the transmission. The filter is just simply retained with a O-ring, pulls right out. And this is something, of course, I would indeed replace on an overhaul, but also could be a maintenance item. Simply putting the bolts back, especially when you have a large number of different length bolts, is a good idea. Now, on this particular transmission, the 10AT, compared to the earlier Honda automatic transmissions, the number of external auxiliaries and bolts is very small. So it's not quite so critical. And one thing that Honda did, obviously, to save money is you'll notice that many of the bolts are exactly the same length. And where there is an exception, one thing, bless their hearts, there at Honda, they actually had placed a little arrow on the case to show you this, and we'll be looking at that more carefully in just a moment. So this is our first step, and I'm going to go ahead and take the transmission heat exchanger and put it off to the side with its filter. Now we'll go ahead and switch over to the transmission controller, and it simply has four 10mm bolts. You'll notice that it's clearly marked there with the Honda part number, and obviously the OEM supplier, Denso. We see the full part number, and our electronic style scan display right there as part of the plastic housing. This could conceivably be removed easily with the unit still in the car if necessary. Just simply carefully pulling it straight out, and there we see its connector. Now I'll go ahead and put this off to the side. Now this would be an example where if I simply put the fasteners back, I wouldn't have to look for them later on. One thing that I can do is I use these little trays to place fasteners in. Okay, after removing the transmission control module, now I'm ready to remove the valve body cover. This particular model is using an aluminum valve body cover, so we'll go ahead and remove the corresponding 10mm fasteners, retaining it to the case. Okay, here we've removed the valve body cover, which is made out of aluminum, and there we see a molded gasket. And of course, we recommend absolutely no type of sealer on this. This is the gasket material itself is what you need to use. And you'll notice that there are only two style bolts, so it's very clear where they go. So we have a long and a short. Now, one thing to be careful of is there is a dowel pin that positions, just one, the valve body cover there to the case, and we want to be careful not to lose that. So we'll go ahead and remove that, and it should easily pull out. Slips right out. Okay, first thing we want to do before we try to remove the valve body is let's go ahead and remove the input speed sensor. So this would be our turbine speed sensor. One 10mm fastener. And here we can see that she slips right out. And here we have a series of fasteners that are holding the valve body to the case. There are two size or two length bolts, so it's very obvious where they belong. And there's going to be two dowel pins, and we want to make sure that we rescue those and don't let them get lost during the overhaul process. Now, one thing Honda has done is they have centrally located all of the solenoids on one valve body assembly. And as you can see, there's quite an array. Pressure switches, solenoids, fluid temperature sensor. Okay, we're going to be very gentle, carefully pulling it away. And as you can see, I have these distribution tubes, and be sensitive to these filters. Now, this is a passage where a clutch is going to be applied and released. So the fluid is going to be moving back and forth, and the idea is to simply capture any material there within the clutch assembly, prevent it from entering the valve body. Now you're wondering what. Okay, here we see the series of distribution tubes and their O-rings. Here we see the suction tube there for the pump, and here we see the actual filter between the sump and the transmission pump, which we'll see in just a moment is actually chain driven. And what I'm going to do is take the valve body assembly and put it off to the side. Now here are the two dowel pins that are aligning the valve body to the case. Now they're strictly a slip fit. Don't let these get lost. Okay, here we see the ground strap between the transmission case and the body of the car. And this is one of those components that I certainly don't want to forget or misplace. This can cause some strange electrical problems with the vehicle. Now we talked about actually putting a bolt back, and this would be an excellent one to put back. No problem. Know exactly where it is, and it will stay with the case, even through the washing machine. Now while we're here, before we actually take the transmission apart, let's talk a little bit about the case vent. This is actually the case vent. So what this is going to do is allow air to exit and enter the case as the transmission heats up and cools down. As you can see, it just simply has a very simple baffle and a vent that usually a vent hose would be installed on to go to a higher location there in the engine compartment. All right, this is going to be the output shaft speed sensor, and actually what I'm doing is I'm looking at the teeth on the transfer gear, but this is going to be representative of vehicle speed. And as we look through the port, we can actually see the teeth there on the transfer gear. As we proceed with the disassembly of any automatic transmission, one thing we want to carefully inspect it and perform a simple air check. What is an air check doing? Is I'm using compressed air regulated at about 30 pounds to actually apply the different brakes and clutches to test their function. Now here with the Honda 10AT transmission, our 10 speeds forward through our 4 planetary gear train sections are achieved with 3 clutches and 3 brakes and a selectable 2-way clutch. In one position it will act as a 1-way clutch, locking in one position, freewheeling in the other, and the other position it locks in both directions. Here we see the lever for the parking pawl, and the parking pawl is actuated solely hydraulically. There is not any type of manual linkage here on the Honda 10AT transmission. All selections of park, reverse, neutral, and forward ranges are controlled electronically. One nice feature here of the 10AT transmission is it uses the same turbine shaft splines as the older Honda parallel shaft automatic transmissions, the 4, 5, and 6 speeds. So here this popular Honda tool used the hold the input shaft, works on the 10AT very nicely. Now with regulated shop air, we'll go ahead and we can actually apply pressure to all of the passages, except of course obviously some of these passages deal with the charging of the converter and the apply of the converter clutch. But let's go down. So let's go ahead and check clutch C1. And I can hear it nicely apply as I apply shop air. Very, very little leakage. And then here we look at the brake B1. Applies without any trouble. No leakage to speak of. Here we see brake B2. And I can actually see it applying there in the case. Doesn't take much, 30 pounds of shop air. Here's brake B3. And here I see clutch C2 and C3. Okay, these are the assortment of bolts that are holding the case halves together. I have the larger 17 millimeter bolt, and then I have the smaller 12 millimeter. And there are 3 of the longer style 12 millimeter bolt, but as you can see, it is clearly marked its location there on the case. And as a general rule, if you put the wrong bolt in there, it's going to be pretty obvious. So obviously, as I place the bolts, I'd like to see a uniform height. Now, something to note, and this isn't just on the Honda transmission, but all automatic transmissions, and I could even say manual, is that it's very important that the input to the shaft and the stator support and the hub and pump drive of the transmission be properly centered and aligned with the crankshaft of the engine. And the way we do that is we use these precision alignment dowels. Now, normally what we expect to happen is for this to stay with the engine, but sometimes it's just a very loose slip fit, and in this case it stayed with the transmission. Now, it's very important that the installer be sensitive to having his alignment dowels. If he were to leave these out and install the transmission, oh, I may get lucky, but chances not. What you'll find is after a few thousand miles, there it's going to tear up the bearing and the pump drive. And usually it'll be associated vibration. So we want to make sure if there's an alignment dowel that we don't lose it and that it gets put back as we install the transmission. Okay, here we're ready to separate the pump halves on our Honda 10AT automatic transmission. Unlike the parallel shaft transmissions, where in the process of separating the case halves, you are having to slip past the outer race of ball bearings. They're supporting the main shaft and secondary and auxiliary shafts. Here with the Honda 10-speed AT, we don't have that situation. So after removing the bolts, retaining the case halves, they should slide apart rather easily. Might require just a little bit of coaxing, but here it should slide apart without too much effort. And there, as we separate the case halves, one thing you want to immediately be sensitive to is you're going to have 2 dowel pins. Be sure and note which half they stayed with. Here we see the transmission filter. It's a pleated style filter. Obviously this is going to be changed on the overhaul. Here we have a nice powerful magnet to catch metallic debris. There's also a magnet on the drain plug of the transmission also. And as we can see, become very popular with many manufacturers is that the oil pump right here is being driven via sprockets and change from the hub of the torque converter. Here we see the distributor tubes with O-rings. Now, I'm going to show this, very important, don't forget this, is at this point, there's a lubrication tube in the transfer gear. You want to make sure you remove that. Don't leave that in there, because it's very fragile and it will be very easy to bend, and it should come up very nicely. There's no O-ring or anything retaining it. Should slip right up. It's retained right here in the case, and it's supplied there with one of the lubrication passages. So be sure and remove this at this time. Okay, now we're ready to go ahead and start disassembling the automatic transmission. First, I have a baffle plate that we need to remove. It's made out of plastic. three 10mm fasteners, all the same length. And you'll notice one thing interesting about the 10AT transmission is, obviously in order to have an economical design, Honda favors using a fairly common length fastener. So I'm not plagued by 10 different length bolts as we were with the parallel shaft automatic transmissions. Okay, now I'm actually ready to start disassembling the automatic transmission. Now as I do so, actually what I'm going to be doing is I remove components. I'm actually going to be stacking them up on the engine side of the transmission case. And so what we'll do is, as I tear down the transmission on this side, I'm going to be building it up there on the other half of the case. All right, now we're ready to go ahead and disassemble the automatic transmission. What makes it easy is just simply place the case halves side by side. So as we remove one, I can just simply slide it down on the other. Now I'm going to have a selective shim and a Torrington bearing. And here we see the turbine shaft. And here we see the C1 clutch. And you'll note, anytime I disassemble a component, make sure that you note the location and the orientation of any of the Torrington thrust bearings. Now, one thing that's nice about the Honda 10AT is they're pretty obvious. Some of the parallel shaft Honda transmission, you had to be real careful because it was easy to flip a Torrington bearing upside down. It was not readily evident of its orientation. So it's usually a very good idea that as you disassembled the automatic transmission, if you need question, be sure and mark with a paint pen the orientation of thrust bearings to their corresponding member. Now you'll notice, and this is kind of true with all of the automatic transmission manufacturers, in order to improve fuel economy, improve efficiency, they've kind of done away with the concept of the bushing. Here we're using Torrington needle bearings and Torrington thrust bearings. So we'll go ahead and continue the process. Now here we see one of the interesting compound planetaries. So I actually have a combination of the two planetaries, two planetary carriers, which are actually splined together, and hiding there internally is the front internal gear. Here we see the front sun gear, and here we see the there we go, right together. Now let's go ahead and move over to the case. Now at this point I'm going to need to remove the B1 clutch. Right, here we see the B1 clutch, and actually when we were air testing the B1 clutch, here's its passage directly here. Now it's retained to the case with three 14mm bolts. They're all the same length. Now keep in mind the torque specs on this. Oftentimes you can look at the size of the bolt and the type of thread to get an idea of the torque spec. Remember that we're going into aluminum, and Honda has favored a basic aluminum case, not the aluminum magnesium of Mercedes and ZF. Here I can go ahead and remove the B1 clutch. Now, it does have two alignment dowels, and so I'm trying to kind of work it past the alignment dowels, just being a little difficult. Okay, after removing the 3 bolts to retain the B1 clutch, we'll go ahead and lift it up, and it's going to be a little bit of a fight to come off of the 2 dowel pins. Do not lose these, and it'd be a good idea to go ahead and secure those properly at this time. So here we have the B1 clutch. And you'll note that what I'm doing is I'm just simply transferring the components here from one to the other. Now it's a little bit tricky. Obviously I have to line everything up to get it to go back on, but as you can see here, it slides right there onto the distribution tubes, and here we see the port through which we were air checking the transmission. Okay, now we move to the 2-way clutch. As you can see, in one position, 3 wheels in one direction, locks in the other. Here it's locking in both directions. So I can use this for reverse and manual low, and there, all the forward gears I can go ahead and take off. This lifts right out. Now I say lifts right out. At this point I'm going to go ahead and have to lift the differential assembly out of the case. All right, at this point I'm going to go ahead and lift the differential assembly out of the case. Slides right out. Now, the tapered roller bearing race is just really a slip fit into the case. It's fairly easy to remove, and sometimes it will slip out by itself. As you can see, slipped out by itself. So there we go. And on one side is going to be a selective shim that determines preload. We don't want to lose that. I don't believe this is the side. So we'll just go ahead and set our bearing race right there on top of the differential assembly. Now, here I can go ahead now and remove the 2-way clutch. This is easily disassembled and inspected. Is very clever the way it looks, and we'll cover the actual disassembly of the 2-way clutch and its internal mechanism in a separate video. So now I'll go ahead and set this over here. And we'll continue our disassembly process. All right. Now, the next part, this is actually the second planetary assembly's internal gear, and is also the output of the transmission. So the internal gear on one side and a output gear on the other. Here we see the transfer gear that transfers the torque to the final drive. Now, as you can see, 2 stout ball bearings are supporting this internal gear and the output gear, and this cast iron assembly is retained there to the case with these 14 millimeter 12-point bolts, all the same length. And at the same time, our parking pawl mechanism and the parking pawl and the parking tooth gear, which is part of the transfer shaft, is here in this area. And here we talked about this. The lever that's actually controlling the parking pawl is hydraulically actuated there with a actuator on the valve body. All right, now I'm ready to remove the 14 millimeter 12-point bolts. Now, it's interesting to note that the bolts that were retaining the B clutch are actually 14 millimeter 6-point. Here, these are 12-point. And they're going to be a rather stout torque. All right. Okay, here I see my 14 millimeter 12-point bolts. Now, these are going to be a rather stout torque. And this would be a good point to go ahead and remove. This is actually an assembly that's going to direct splash oil to one of the carrier's bearings. So here the differential carrier bearing is going to supply beside lubrication from this baffle. And as you can see, it's catching the oil and directing it. However, if we look here at the case, you can see it's actually being fed actively too. So pause. Okay, here we can see that this is one of the lubrication passages and lubrication nozzles to make sure we have ample flow of lubricant that's going to be supplying one of the differential carrier bearings. All right, now we're going to go ahead and remove the 12-point 14-millimeter bolts retaining the output and the output internal gear there to the case. Now these are going to be a stout torque. We need to use a 14-millimeter 12-point. Now in an emergency, I guess I could use a 9/16 12-point socket, but if you do so, I strongly recommend don't use an impact, but just simply use a ratchet and extension to remove those bolts, because I sure don't want to strip them off. Of course, they are good stout steel, all the same length. Now, as I remove the output internal gear from the case, I'm going to have to take the transfer gear with it, so they'll have to come out as a set. So here we go ahead and pick up a little bit. And again, I'm going to have a little bit of a fight, because not only do I have two alignment dowels, but I have to kind of pick up the transfer gear at the same time. Kind of work everything out. Here she comes. And we'll go ahead and set this up here on the other case half. I'm going to have two alignment dowels. Be sure you rescue them, both of them, from the case. Know where they are. And now I can just simply remove the transfer gear, and you can see the parking gear and the parking pawl. Note, let's take a careful look at the orientation of this spring. Now the spring is holding the parking pawl obviously in the release position, and when I move the lever, of course it's forced against the parking gear. Let's take a look here. We see a conventional method where if for some reason the pawl won't engage with the gear because of its position, what happens is I can still move it to the selection of park, but then I simply compress this spring until the vehicle moves slightly and the parking pawl can snap or index into the parking gear. Okay, here we're going to go ahead and remove the parking pawl assembly. Note the orientation of the spring. Over the years, especially Ford, I seem to have problems with the design of a parking pawl and a parking system. So there couldn't be anything more important, because as I place the transmission in park, I'm expecting the parking pawl and the parking gear to hold the vehicle in position, even on a steep incline. I know the owner's manual recommends using the parking brake, but come on, a lot of owners don't even know where it is or how it's used. So this could not be overemphasized. Okay, so here we can Continuing our disassembly process and reassembly here on this case half, here I have slipped on the output internal gear and the output to the transfer shaft, and our differential assembly will slide right here into the case. You'll notice that Honda, kind of taking the clue from Mercedes, is using that elastomer coated aluminum gasket there. I'm going to be very sensitive to that. Obviously no sealer, and under no circumstances should I insert any type of pry tool between the case halves when disassembling the unit. All right, so now let's go ahead and continue on. So now we can continue the disassembly process. Here, removing the sun gear assembly. And note, if there's any type of thrust washer, be sure and pay close attention to its orientation, and I see it right here. Notice, obviously, what I'm doing is painting a gear if I have any question about its orientation. Obviously, some of these may be symmetrical. But you'll notice here on this sun gear, there's a groove there on the bottom, and there on the top, there's not. So obviously, this is not symmetrical. So we want to pay real close attention to its orientation. Here we see one of our thrust washers. One of our spinning clutches. And here it's coming apart quite nicely. Now, one thing we want to be very sensitive to at this point is here I have one of the sun gears, and I actually have a selective shim. So I want to be very sensitive about that selective shim. Don't lose it, don't let it get away, and actually make sure it stays in its groove, because it's real easy for it to get offset as I assemble the transmission, and you wonder, well, why? Well, as the case comes together, it should slip right together, flush. If for any reason it does not, you've assembled something wrong. Obviously, just a simple little bit of assembly grease would keep that nicely retained. Okay, we're continuing on. Okay, now we're ready to move to one of the brakes. Now this is a little bit tricky and requires a special tool setup. I'm sure Honda has a very special tool. It might be as simple as a section of aluminum that uses one of the bolts to compress the spring. Now I don't have that, so I'm going to go ahead and set up my assembly and compress the spring to remove the snap ring. Now I suppose you could force it out, but that would be very sloppy, mar the case, mar the assembly, and would be very difficult to reinstall like that. Okay, here we're ready to remove one of the brakes. Now I'm going to have to compress the release spring assembly in order to remove the snap ring. Now I'm sure you can come up with a method. What I actually have here, this is actually a piece from a 4L30E. It's actually slightly modified, and it just so happens to set very nicely. And this is just a section of plastic pipe, a couple of pipe adapters that I just simply got from my local Lowe's. Just so happens to fit nicely. What am I using here? This is just a piece of hardwood. It's again purchased from my local Lowe's. And what am I going to do? I'm just going to simply thread this down and remove that snap ring. Now, one of the advantages of using plastic and hardwood is this will not mar the aluminum or scratch the finish. Also, in case you do something foolish, oftentimes the plastic or the wood will give before the components of the transmission are severely damaged. So here I'm just simply torquing this down. As you can see, it's nicely compressing the spring, making it now possible for me to remove the snap ring. And as you can see, what's happened is we have pushed this down, and now the snap ring will slip right out. Now, obviously, as you can see, there's a locator, which we're going to look at in just a moment as we disassemble it. So the snap ring only goes in one way. All right, so I'm going to now remove the snap ring. I've compressed the return spring, so the snap ring should lift very nicely right off. Oh, here we go. I can just simply pick it up. Whoop. And go and work around. Carefully pick it up. Just don't scratch. And I got it started, so she's coming. Give it a little push. Coming around, give it a little push. She's almost out. One more. And here she comes. So now the snap ring is clear from its groove, so I can go ahead and remove the hardwood board, plastic pipe, there we see our snap ring. Here we see the clutch pack. They're using the conventional frictions and steels. Here I have a wave plate. And there we see the piston return spring. Now, method of removing piston. Well, this time I can go ahead and lift out this internal gear. I'll go ahead and do that. Note very carefully the orientation of the Torrington bearing. I'll go ahead and slip it down here on the assembly. Now this shaft actually splines into the input shaft, and so here this clutch assembly can be used to grab the rear internal gear and either lock it to the turbine shaft or lock it to the case. So we'll go ahead and slide this together. Okay, at this point we want to go ahead and remove the brake pistons, and there are actually two of them here. So what I've done is I have removed one, and we just reach in and remove the other one, and these slide together. And of course these O-rings would be replaced during the overhaul. And here we see the passage there for this brake is right here. So we'll go ahead and put this off to the side. Now, we have two snap rings that we need to remove, and the first snap ring is retaining the piston and housing for one of the brakes. It really doesn't make any difference where the opening of the snap ring is. However, when I disassembled the transmission, they were very nicely aligned, which suggests some type of robotic or automatic assembly. And both snap rings are identical. They're not real stout. I'm just going to simply use this set of snap ring pliers to remove the first one. The second one, I'm going to first have to compress that piston. So here I just simply squeeze the snap ring, just reach in with my hand, and just very carefully lift it out. Now, again, the same thing. There we see this is actually the piston and housing. Here is the piston, there's the housing for this brake. Now I'm going to have to push this down, so again I got to fabricate some tool that's going to allow me to push this down to remove this snap ring. There we go. Now what I've done is fabricated a tool to very carefully depress the spring assembly for this brake. Now this is my 4L30E component, slightly modified. This is my favorite spring compressor, turned around backwards. And this is just a simple length of PVC pipe. And there I see my hardwood board in the same locations. Give this thing a little push, doesn't take much, and I can easily remove and install the snap ring. Now keep in mind, with my setup, I'm only pushing on the piston, not the housing. Well, once I push the piston down, the housing slides very easily in the case, and you'll see what I mean in just a moment. So now what we're going to do is give this a little bit of a push. And again, using hardwood and plastic. Certainly this isn't going to mar or scratch the aluminum. Easy on components. Now I've compressed that spring, so now I should be able to reach in here fairly easily and remove the snap ring. Just positioning the snap ring so I can get my snap ring pliers in there, give it a little squeeze. Whoops. And out she comes. If you see the snap ring is sliding along, well, you know for sure that, hey, it must not be under tension. Okay, after gently squeezing the snap ring, I'm just reaching this plastic trim tool. And again, I like using the plastic trim tool because I'm not going to scratch anything. And I just reach in there and pick up the snap ring. And I should be able to just gently pick it up without any problem. And here she comes. There we go. Both of these snap rings are the same, identical. Same thickness, same size, same tension. Now I can go ahead and relieve tension and remove the piston housing, the piston, the return spring, and the clutch pack. Whoop, there's my tool. Forgot to take out my trim tool. Here we go, but it's made out of plastic, didn't scratch or hurt anything. And now I'm getting ready to lift the piston and the housing up. Now remember, I got to pull it past this little ridge right here, and there's some O-rings there. So sometimes it's a little tight and a little tricky. Okay, here I'm using a combination of the twin trim tool with this port here on the side to carefully select or separate the housing from the piston. And once I do that, it is much easier to slide it out. And again, what am I fighting? Well, what happens, there's an O-ring on this, and the O-ring wants to get caught there in the case. So here we see the housing, here we see the piston, and through the port, right here in the side, I'm going to be applying this brake. And here we see the clutch pack and the return spring. Now, we're getting closer to an empty case. Now, this bearing race is actually just a slip fit into the case. And I don't know if you can see this on the camera, but you can see that I'm actually grabbing it with my hand and turning it. And you'll notice it will almost fall out by itself when you turn the case up. There isn't any type of selective shim on this side. It just goes right down against the case. Now, you can take your snap ring pliers and remove this snap ring. This bearing is a light press fit in the case. It's a little tricky to pull out. You can remove this snap ring and pull this inner housing out. And as you can see, it kind of floats around. And this is what Toyota has used in the past with their parallel shaft transmission. I actually have a small bushing and a large bushing there in the input shaft. And this I can use to apply hydraulic pressure to 2 of the clutches. Okay, here we see the Honda 10AT transmission disassembled and then reassembled. And then here obviously is the engine side case half. We can see the oil pump. Here we see the two-way clutch. Here we see the output internal gear, parking pawl gear. Here we see the transfer shaft and the differential. Swinging around. We can see the parking pawl and parking gear. And here we see our lubrication section. One thing that we had talked about was this oil weir, and what this is going to effectively do is direct lubricating oil to this carrier bearing. I'll slip right over here, obviously. There we see it, the 10AT automatic transmission. Now, quite a bit more involved, obviously, going through the clutches and rebuilding them. You can see these 2 brakes, kind of self-explanatory if you had to disassemble them. Here we see the rear Torrington bearing. And we saw, of course, the distribution tubes going to the corresponding bushings down inside the input shaft, there to apply to the spinning clutches. Okay, here we see the 10AT case disassembled, and we had talked about this bearing cup there for the tapered roller bearing for the transfer shaft. As you can see, it's a slip fit. It's going to resist me here actually pulling it out with my hand, but as you can see, I can grab it and just spin it there in the case. Now I helped it out with a little bit of lubricant, and as you can see, the bearing cup for the differential fell out by itself. The selective shim is not on this side. And here we go. Let's take a look at our case. Oftentimes, Honda used to like to give a four-letter designation to their transmissions, like BYBA. Well, here, now it's PMXA. I believe that's what they had in mind. Here we see this is the port for the case vent, and there we see, of course, the motor mount. Here they were nice enough to include this lower motor mount. We got a few places where there's possibly a pressure tap, but not like on the parallel shaft transmissions. And oftentimes these pressure tap ports were necessary there in the manufacture of the transmission. Now, this case is made out of what appears to be pure aluminum. It's pretty stout. Now, obviously, this transmission's only been out for, I guess, 18 months, 24 months, so time will tell. It's under warranty. It'll take a while before it gets to the shop. But won't be long, and hopefully, if this is a successful transmission, this will be a good money maker for our transmission shop.